For those of you just joining us, you want to get out your 162 homework assignment. And what we're going to do is go over the homework assignments from page 162. And then I'll answer any questions you have on any of those homework assignments. And I'm almost done grading your 3-6 chain rule quizzes. They'll be in probably before the end of the day today. So what I'm going to do is based on how those quizzes went, I really feel like there's some areas we need to go back to and focus on, especially before going into break. So I've been sort of mapping out where we are, where we're going. We're going to finish 3-7 before break. You guys will have a quiz on that before you go into break. I have created a packet for break for you to work on. That should be done and ready as a PDF for Monday. And basically what we're going to do is use that packet over break to utilize reviewing sections 3.1 to 3.7. When you come back from break, we'll use those first 4 days to review for your mid-chapter 3 test. So if you're somebody that likes to plan ahead or you like to know, your mid-chapter 3 test will be that Friday we come back from break. Now, if we are told we are going remote for that first week back, then I will push your test to Monday because I would prefer your test to be in person. If we are hybrid, then your test will be over the course of those 2 days with multiple choice on your in-person, on your remote days, and a free response on your in-person. Now again, these are all ifs, whens, hows, and whats because we have no idea what the schedule is going to look like for that first month back into January. So that's just me planning ahead, trying to figure out what we're doing, but that week back, there will be some sort of mid-chapter test. So that being said, based off those quizzes, the area I saw our biggest issues with was trig. So I want to make sure we really go over these implicit trig derivative homework problems to make sure we're fully understanding them. So that being said, here is the work and solutions to that trig derivative homework assignment. So on page 162, we did 5 through 8 the other night. So hopefully for number 5, you got that cosine squared y. Number 6 is 1 over cosine y, which is the same as secant y. And then 7, this is where 7 gave us problems on the quiz. 7 is actually very similar to one of the questions I really wanted to talk about, which is that when you have a trig derivative and it has a product inside, you have to make sure that you apply the chain rule. A lot of our errors were that we forgot to take the derivative of the inside of the trig functions, especially if the trig function was just a like a number and a x multiplied together. So like pi x, well, that one really tripped us up. So here we have the chain rule and implicit sort of combined. So the chain rule says you take the 2 first, and then that gave you your secant squared, or in this case, because it was the derivative of tangent was secant squared xy. And then it's the derivative of the inside of that tangent xy, which gave you x dy dx plus y dx dx equals 0. Now, as we are kind of moving further and further into implicit, you can get out of the habit of writing dx dx again. I have you write that at the beginning, really to kind of reinforce reinforce the fact that the derivative of x is dx. To understand that it's the derivative of x with respect to variable x, which means it's like a 1. So now that we're a few days into implicit, you no longer have to give me those dx's. I don't need to see them. So again, there's your final answer for 7. You could have had either of these. I would have accepted both. And then over here is number 8. So again, you can see I kind of have these ors because sometimes we simplify differently or we multiply, subtract differently. So you can see how like this person had y minus 1 over cosine y minus x, or it's equivalent if you'd factor out a negative and redistribute it, gave you 1 minus y over x minus cosine y. So sometimes implicit's a little tricky because you can have the same thing but slightly different. So that was 5 to 8. Jumping down to 23. Okay, jumping over to 24 and 25. And again, guys, if you're checking these and you're confused or you don't know how I did something, do not hesitate to ask. Okay. I wondered. I put my notes in. Here's 27. Okay. And then 27. Maybe if it wants to unblur. There we go. Okay. 27 and most of 28. I'll move down for you in a second. Okay, there's 28. And then 29 and 30. And then jumping back from 30, we went to 41 and 42. Poorly hole punched. Okay. So I know I went over every homework problem, but that doesn't mean you still didn't have questions for me. Is there anything you saw or didn't understand that you would like to go through a little more in-depthly?
Are you going to post the answer key somewhere else so we can look at it like later or something?
Well, I am recording all of this, so it'll be at the beginning of the video, so you could go on to the video and just like pause it on any of the problems you want to see.
Okay, thank you.
You're very welcome. Okay. Cooper. Should be waiting on 2 others. Tangent. Sine. Okay, so derivative of sine is cosine. Derivative of sine is cosine. Great job. What is the derivative of cosecant? So derivative of cosecant is negative cosecant cotangent. Again, derivative of cosecant is negative cosecant cotangent. I don't know why it keeps going through that question. What is the derivative of cosine 5x to the 4th? all got that right. So again, derivative of cosine is negative sine. Derivative of 5x to the fourth is 20x cubed. So it went out in front. Fantastic. Great job. Awesome. So derivative was negative 5. So again, remember guys, the 5 actually happens before we take the derivative cosine. So it's 5 cosine 4x times derivative cosine, which is negative sine. So that's where you got the negative for the negative sine, 5 for the power, cosine 4x times sine x. Awesome. So, good job. Derivative of tan gave you secant squared, and then you had to multiply by the derivative of the inside. Great job. Awesome. Okay, so this problem was a product rule. So you had to do first times derivative of second plus second times derivative of first. So you knew you needed to have two parts when you gave your answer. So again, when I'm looking at those answer parts, I knew it couldn't be the answer that just had multiplying. So tangent times derivative of cosine plus cosine times derivative of tan. So this one was a chain rule. You had to first take the derivative of the outside. So it was a 7. Take one away. So you had 7 quantity cosecant x plus 1 to the 6th times derivative of cosecant, which was a negative cosecant cotangent. Derivative of 1 is 0. So I gave you this negative 7 cosecant x plus 1 to the 6th times cosecant cotan. Okay, so I put this one on here because this was one of the most commonly missed questions on our last test. And it's still a commonly missed question, so I'm glad I put it on here because I really want to talk about it. So basically, this problem, you need to go and understand the fact that pi x is considered a part of a function. So really, this is a chain rule. So you have to start by taking derivative of sine. So the derivative of sine is cosine. So that leaves you with cosine pi x. But pi isn't any different than any other number. If that was cosine of 2x, then you would know to multiply by 2. Well, cosine of pi x is the same. Pi is 3.14, and on and on and on. So this has to be times the derivative of the inside. Well, the derivative of pi x is pi. Just like the derivative of 2x is 2. So your answer is pi cosine pi x. You can guarantee there will be some form of this question on Tuesday's implicit quiz. So you can guarantee there will be some form of a sine pi x on Tuesday's quiz. Now pay attention. And, okay, so I even gave you the warning. Pay attention. Guys, cosine pi. Cosine pi. There was no variable here. Cosine of pi on our unit circle is -1. What is the derivative of -1? 0. You need to be very, very careful. Cosine of pi is a constant. There is no variable in there. So the derivative of a constant is 0. The derivative of a constant is 0. And again, those of you guys participating, I know these are kind of trickier. These are the questions I'm noticing we're making errors on. I'm picking them on purpose. So that was like the last question that I had thrown on into our review. So let's see our leaderboard. So since there were 5 of you participating, the 5 of you that participated, all 5 of you got a 5 out of 5. So yes, today you are working on that circuit review handout. That is due on Monday. On Monday, we're going to do another kind of review Kahoot quizzes lesson. And then we are also going to go over that circuit paper. And then I'm going to give you your review packet for break. And then, to be honest, I think I opened the AP classroom quiz already to start on Monday when class time ended. So on Monday, you should be able to start the AP classroom quiz if you're ready to take it on Monday. If not, you have through the end of the day on Tuesday. Okay. For this problem here, it says for the circle centered at the origin with radius 4 and equation x squared plus y squared equals 16, find dxdt at the first quadrant point where x equals 2. If I think it should just, are you concerned because there's a t? I'm pretty sure I just typoed that.
Oh, yeah.
Like, it should be, so, okay, let me pause, hold on, because I have my answer key as well. There, it is a parametric. So basically what happens is you follow all your rules the same. Think about the fact that it says dx, so it's the derivative of x, with respect to variable t. So that means that every time I take the derivative of a variable, the base is dt. So since these are all x and y's, just like when you take the derivative of y with respect to x, when I take the derivative of x and y with respect to t, that dx dt and dy dt are both going to stay now. So you're not going to end up with that dx dx because we're taking the derivative with respect to t that doesn't even really appear in our problem. So we get 2x dx dt plus 2y dy dt equals 0. And then they tell us x. You can find y by plugging x into the original. So you'd have 2 squared, which is 4. 16 minus 4 is 12. So that's where we got the y is equal to the square root of 12. So that's where that comes from in our problem right here. So then you plug in x, which is 2, y, which is square root of 12 that we got from plugging it in. And then they told me dy dt, so I plugged that in. And then you solved for dx dt. So again, that's a variation of a parametric. We don't have to do those because they are on CHS. And I thought I got rid of them, but I did not. So now I'm going to go scroll through the rest of this circuit and make sure I didn't leave them on there again.
That makes perfect sense. Thank you very much.
You're very welcome.